Welcome to Easy Elim Learning Simplified. So today we are going to be looking at the topic mole, and specifically we are going to be looking at the molar gas volume. So we look at what molar gas volume is, the Avogadro's law, and then we'll do a few questions. So atomicity is the number of atoms of constituent elements combined to form a molecule. So when we talk about atomicity, we know there are some molecules that are made of one atom, such as helium, neon, argon. We usually call them, they say that they have an atomicity of 1. The ones that are made up of 2 atoms, similar, for example, hydrogen gas, nitrogen gas, oxygen gas, usually have atomicity of 2. We have monoatomic in the case of the atomicity of 1, diatomic in the case of atomicity of 2, triatomic like ozone with the atomicity number of 3. So when you look at the Avogadro's law, it states that equal volume of gases under the same conditions of temperature and pressure contain the same number of molecules. So we know that the volume of gases can be affected by a change in temperature and pressure. So Avogadro's had used constant temperatures and pressure, and the volume of gases realized usually contain the same number of molecules or moles. So which are these conditions? So the two conditions, the molecular formula before we go to the condition is a volume occupied by 1 mole of a substance at a given temperature and pressure. It's the same as the molecular mass being divided by the density, and the SI unit is m cubed per mole. And the molar gas volume is calculated under these conditions of temperature and pressure. So we have the STP and RTP, just like we mentioned when we were doing the combined gas law. But in this case, now it's going to relate to the volume. So 1 mole of a volume of 24,000 centimeters cubed or 24 liters is at room temperature and pressure, which is at 25 degrees Celsius, 1 atmosphere. So that is going to be 24,000 centimeters cubed or 24 liters. And remember, this is 1 mole. And then at STP, it's going to be at 0 degrees Celsius and 1 atmosphere. But the volume that is going to be occupied by that gas is going to be 22.4. This is liters. This can't be centimeters cubed. This is going to be 22,400 centimeters cubed or 22.4 liters or 22.4 dm cubed. So we are going to be using these standard conditions of gas volume to do some calculations. For example, 58 centimeters cubed of a gas at STP has a mass of 5 grams. So we have the volume, which is 58 centimeters cubed. We have the mass, which is 5 grams. Calculate the relative. So we are looking for RMM. If you are given the molar gas volume is at STP, which is 22.4 dm cubed. So for us to get the relative molecular mass of any compound, we need to have the mass and the moles. So we already have mass, so we are going to calculate the moles, and we can get the moles using the molar gas volume. So we know that as STP 1 mole is equals to 22.4, in this case dm cubed, or 22,400 centimeters cubed. Remember, 1,000 centimeters cubed makes 1 dm cubed. So in this case, we have 22.4 dm cubed. So that means we are multiplying 22.4 times 1,000, which gives us, this one cancels, which gives us 22,400 centimeters cubed. So what about 58 centimeters cubed? So we cross multiply, so it's 1 mole times 58 divided by 22,400. Let's see how many moles took part in this reaction. So it's going to be 0.0025 moles. So now if you look at the formula of calculating molecular mass, now we have mass which is 5 grams and the moles is 0.00259, which gives us 1030.5. This is the molar mass. Another question, calculate the mass. So we are looking for mass. So mass is usually equals, so we know moles is equals to mass over molar mass. So it means mass is going to be moles times molar mass. That is when you multiply molar mass both sides, you get this. So this is what you are going to use. Mass is equals to moles times molar mass. So you have been given the volume is 120 centimeters cubed of nitrogen gas at RTP. So you have been given the molar gas volume at room temperature and pressure is 24 dm cubed, which is the same as 24,000 centimeters cubed. So what you're going to do is get the moles because the molar mass we have. So the molar mass of nitrogen is 14 times 2 because it is N2, which gives us 28. So the moles, we know 1 mole of our gas at RTP is equals to 24,000 centimeters cubed. So what about 120 centimeters cubed? So it's 1 times 120 divided by 24,000, which will give us 0.005 moles. So our mass is equals to moles now, which is 0.05 times molar mass, which is 28, which gives us 0.14 grams. So one last question, calculate the volume of carbon dioxide measured at STP, which evolved when. So we have the mass, which is 4.2 grams of magnesium carbonate is heated to a constant mass. So when you look at the formula, magnesium carbonate, when we heat magnesium carbonate, we form magnesium oxide plus carbon dioxide gas. So we are basically looking for the volume of carbon dioxide. That tells you we need to get the mole ratio, which is 1:1:1. So we get the moles of magnesium carbonate, which we have been told is 4.2 mass. The mass is 4.2. So we need to get the molar mass of magnesium carbonate, which is 24 plus 12 plus 16 times 3, which gives us the molar mass as 84. So the moles will be 4.2 divided by 84, which will give us 0.05 moles. And if we use the mole ratio, we know now the carbonate also is going to have 0.05 moles. So we go back at STP. We said at STP, 1 mole of our gas is equals to 22,400 centimeters cubed. So what about 0.05 moles? We'll have what volume? So when we crisscross, we get 0.05 times 22,400 divided by 1, which gives us 1120 centimeters cubed. So that brings us to the end. So in the next session, we are going to look at Gay-Lussac's law. So see you in the next lesson.